I'm coming to you with these real quarantine vibes for this intro for this video. Before we get into the lesson on graphing exponential functions, what I need you to do first is grab your phone. If you have an iPhone, I know you can find it. If you have an Android device, look in the description below for the app that you can download, but you need to download the Calculator 84 app. It's perfect. It looks exactly like the app that we use in class, the TI-84 Color Edition or CE, right? So this is perfect for you to download, especially since we're learning from home. So that way you get the same calculator experience we would have had if we were still in class together. To my students, I love and I miss you all, and I hope you guys enjoy this video, but don't forget to like, share, and subscribe, and let's go ahead and get into it.
So for our first example, we're going to look at an increasing exponential function. We're specifically looking at the function f of x equals 2 to the x power. And then we see we have in brackets -2, 2. This is interval notation telling us that our domain for this function is just going to be from -2 to 2 for our x values. And because they are including the -2 and the 2 with those brackets, we need to make sure we include those values in our x values when we are graphing this function. So I've put the x values in this table already, and because we know f of x can also be written as y equals, in the table I just put it as y equals 2 to the x power. Now we just need to calculate our y values and then write these as coordinate pairs so it's easier for us to plot them on the coordinate plane. So I'm going to start just by rewriting this y equals 2, and everywhere that I see x, every time that I do this, I'm going to substitute that in with the specific x value. So we have y equals 2 to the -2 power. When we calculate that, I'm going to type that into the calculator, just hitting 2, then the little caret that's under clear to give us our exponent, and then typing in -2. And I get 0.25. So I know that this y value is 0.25, and when I write it as a coordinate pair, it's -2, 0.25. Now I'm going to do one more point, and then I'm going to fast forward through the rest of the points on the table, but we're doing exactly the same thing. We're going to rewrite y equals 2, then for our exponent, because the exponent is x, that's where I'm going to plug in this x value that I have here, and then we're going to calculate that. So in the calculator, just typing in what comes after the equal sign, I'm going to hit 2, press the caret so that I get my exponent, type in -1, and then press enter. And it gives me that y equals 0.5 when x equals -1. So I have my y value here, and I'm going to write it as a coordinate pair. Now I'm just going to fast forward. I'm doing, again, exactly the same thing for these next 3 points that are being graphed for our function, and then I'll come back to you guys. Okay, so now we've filled in our table completely. We've written all of our points as coordinate pairs. A lot of those last 3, you guys should know from your exponent rules, from calculating exponents. So you definitely didn't need the calculator to do those last 3, but it was definitely helpful just as some reassurance that we know 2 to the 0 power is 1, 2 to the first power is 2, and 2 to the second power is 4. So we've written all 5 coordinate pairs that we need in order to graph this function. So to plot my first point for this graph, I know the x value is -2 and the y value is 0.25, which is just a quarter of the way between y being 0 and y being 1. So when I go over to x equals -2, I just want to go up a quarter of the way before I plot my first point. When x is -1, I want to go up about halfway between y is 0 and y is 1 to make that second point on the coordinate plane. Then when x is 0, y is 1, so I start at the origin and I just move up 1 unit. Then when x is 1, y is 2. When x is 2, y is 4. So now that I've plotted all my points, I can go ahead and draw a line going through these points. And I also have to remember to label this because we know this function is 2 to the x power. Looking at this exponential function, it's a lot different than the linear functions we've worked with in the past. It's not a straight line, it's a curved line where the y values are really, really small and they're not quite hitting the x-axis yet, but they start to increase very rapidly. And before I say I'm officially done with this problem, last thing I want to do is actually check my graph. Using the Calculator 84 app, it looks just like the TI-84 color edition that we use in class. I'm going to hit y equals, and then I'm going to type in this function, just everything that comes after the equal sign. So in that first line where it says y sub 1 equals, I'm going to type in 2, hit my caret so that I have it, type in an exponent, and then type in x. So I have the same function that we just graphed by hand, 2 to the x power. Then I'm going to hit graph right under that window. And the beautiful thing about this app is that you can move around the window the same way you would if you were zooming in on a picture on your cell phone. So I can see by this scale, the x values are listed all the way at the top of the window, and the y values are listed on the left and right side. I can see that when x is 0, y equals 1, just like the point that we got, and just like what we plotted on the coordinate plane. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. And then it's more difficult to see those first 2 points that we had plotted. If I zoom in, I can see that when x is -1, y is 0.5. And then when x is -2, it's much harder to see because it's such a small point, and to zoom in, it would be really difficult, but I can tap the graph itself and see that the x value at the bottom of that window, x is -2, y is 0.25, which is exactly what we calculated and what we plotted on the coordinate plane. Spoiler alert for this next function, it's going to be a decreasing exponential function. We don't see any negative signs in our function itself, but when we calculate this, you'll see exactly why it plots as a decreasing exponential function. So our function for this example is g of x equals 1/2 to the x power, and that 1/2 is in parentheses because that exponent applies to the entire fraction, not just the numerator, not just the denominator. And our domain for this example is the same as our domain for the last example, ranging from -2 all the way to +2, and it includes -2 and +2 as well. So like the first example, I'm going to rewrite this function and substitute the x value in where I see x in the equation. And I'm going to do that for all of these. So I just wrote all of them in this column because I was writing the exact same equation, just substituting in different x values. Now I'm going to go ahead and calculate them. So on the calculator, I'm going to type parentheses 1 divided by 2 and raising that to the -2 power. So my y value here is 4. And the first coordinate is -2, 4. So that's one way you can type a fraction into the calculator. Another way is to hit your parentheses and then press alpha, y equals, tap that first one that says frac, the abbreviation for fraction, and then type in 1, arrow down so you can type in 2, then arrow to the right so you're outside of the parentheses, and you can type in your exponent. So our second y value, +2, I'm going to write this point as a coordinate. I'm going to go ahead and fast forward and calculate the rest of these and come back to you guys. Now I've got all of my coordinates. I filled in the table entirely. We just need to plot these points now on the coordinate plane. So when x is -2, I'm going to go all the way up to y is 4. X is -1, y is 2, and that's where my second coordinate goes. X is 0, y is 1, x is 1, y is 0.5, so that's about halfway between y being 0 and y being 1. X is 2, y is 0.25, so that's about a quarter of the way. And then to draw a line through these points and labeling our function g of x equals 1/2 to the x power. And now to check that my graph is correct, I'm going to hit y equals on the Calculator 84 app, type in this function, and then hit graph. Now I can see the shape of my graph looks similar, and this time instead of just looking visually at the graph to check my coordinates to see if they're correct, I'm going to hit second graph so that I see a table of values, and I'm just going to see if that matches the table that I created. So if x is -2, y is 4, and x is -1, y is 2, x is 0, y is 1, x is 1, y is 0.5, and x is 2, y is 0.25. So I know my values match and I know my graph is correct. Example 3 looks a lot like the first example we did. The function is almost exactly the same, but this time, instead of looking at 2 to the x power, we're going to look at -2 to the x power. And I want to specify there are no parentheses here. No parentheses here. Keep that in mind. So if you're watching this video and following along with the note sheet, go ahead and pause me right now so that you can fill out this table yourself, and then press play so that you can check your table with mine. Great, so your table should look just like this. And I typed it all into the calculator as well, just so you guys could see these values. Sometimes people make the mistake of putting that negative sign in parentheses. Because there are no parentheses around -2, the exponent only applies to the 2. The exponent only applies to the 2. Right? So all we're doing is basically putting a minus sign or a negative sign in front of all of the y values that we had calculated with the first example. Only difference is that now all of our y values have become negative. Now go ahead and pause me again and plot all of these on the coordinate plane. Now that you're done plotting that on the coordinate plane, it should look something like this. And I also typed it into the calculator just so we can see what that graph looks like. And it looks visually similar to the graph that we created. I'm going to zoom in a little bit so that we can get a more accurate picture. And then also hit second graph so that we can look at this table of values as well. So when x is -2, y is -0.25, x is -1, y is -0.5, x is 0, y is -1, x is 1, y is -2, x is 2, y is -4. So we hit this on the nail. Our graph is amazing. It's adorable. Example 4 is almost exactly like example 2, but with this, just like with example 3, we're putting a negative sign in front of our function, and we are not including that negative sign when we do these calculations in order to write our coordinate pairs. So go ahead and pause the video again, fill out the table, and then come back and check your table against mine before you plot this on the coordinate plane. Now my table's complete. Go ahead and check yours against mine. Check to see if you made any calculation errors. I made sure that when I typed these into the calculator, I only put parentheses around the fraction and made sure my exponent was typed in as an exponent. My negative sign in front of that fraction was outside of the parentheses to help avoid any calculation errors. Now, pause one more time and go ahead and graph this. Visually, the graph I plotted by hand looks similar to the graph that is displayed on the calculator. And I'm also going to look at the table just to confirm that my coordinate pairs are correct and I plotted them correctly, which we did. So it's that simple. First, calculate your coordinate pairs, then plot the points on the coordinate plane and draw a curved line connecting those points, and never forget to label your graph with its function. So a huge question we need to ask ourselves here is how does that negative sign transform the exponential function? So what I'm first going to do, instead of doing these by hand, I'm going to use the Calculator 84 app and plug these in so that I see them on the same coordinate plane. So when these plot, example 1, which was f of x equals 2 to the x power, is going to be plotted in blue. And then example 2, I'm just going to hit that second line there, y sub 2 equals, and I typed in example 3, which was negative 2 to the x power. And I'm going to hit graph so that I can see both of these simultaneously. So if we look at these, example 3 is just a reflection of example 1 over the x-axis. These literally look like mirror images of each other if we were to fold them in half at the x-axis. But is that the same thing that's going to happen if we look at example 2 compared to example 4? Just like I did with example 1 and example 3, I just plugged in example 2 and example 4. Example 2, which was 1/2 to the x power, is going to plot in blue, and example 4, which was negative 1/2 to the x power, is going to plot in black. And when we look at this graph here, the exact same thing happens. Example 4, so when we put the negative sign in front of the function, makes it a mirror image of example 2, which was 1/2 to the x power. If we were to fold this in half at the x-axis, the functions are mirror images of each other, reflections of each other over the x-axis. Hope you guys enjoyed this video, found this video helpful. If you have any questions or comments, you can leave them in the comment section below. You can find the next video in this series linked below on Miss Passarella's YouTube channel. Don't forget to like, share, subscribe. When you head over there, don't forget to tell her she's adorable. I'll see you guys next time.